Hello, let theta be an angle in standard position with xy a point on the terminal side of the angle. And also let's let r be the distance that point is from the origin. Now, the next part of this, I want to discuss quadrant angles. Those are the ones where your angle falls either on the x-axis or the y-axis directly. As a reminder, the definitions for trig functions of any angle, these are their ratios. Your initial side's on the positive x-axis. Your terminal side is at some point. For the examples we're about to do, they will lie exactly on an axis. For simplicity, I'm going to pick angles where we can also pick an easy point to work with, specifically the ones that are 1 unit away from the origin, so that r will be 1 for all our cases. Okay, so let me scroll up and then we'll look at some problems. All right, our first example, we're going to use the coordinate plane to find the exact value of each quadrant angle. So if you're given something like sine of pi over 2, which in that's the radian measure, in degrees you would have sine of 90 degrees. Pi over 2 or 90 degrees fall on the positive y-axis. Now, to keep the distance from the origin to our point at 1 unit, I choose the point 0, 1. Recall that sine is defined as the y-coordinate over the distance from the origin, y over r. So my y-coordinate is 1, and I've carefully picked a point that has a distance of 1 from the origin. So sine of pi over 2 or sine of 90 degrees, that's equal to 1. In red, our middle example, cosine of pi is equivalent to 180 degrees. So if we start on the positive x-axis, rotate around pi radians or 180 degrees, we land on this red terminal side. Again, for simplicity, I picked a point 1 unit away from the origin, so that's negative 1, 0. Cosine is defined as the x-coordinate over the distance from the origin. So the x-coordinate is negative 1 over 1. That's the distance from the origin for an overall value of negative 1. In green, and your farthest right example, tangent of 3 pi over 2, 3 pi over 2 radians is equivalent to 270 degrees. So starting on the positive x-axis, rotating 3 pi over 2 radians or 270 degrees puts us on this green terminal side. 1 unit from the origin puts us at the point 0, negative 1. Tangent is defined as the y-coordinate over the x-coordinate, negative 1 over 0, and that's undefined. Turns out that pi over 2 is also undefined when it comes to tangent. Any vertical angle will be undefined because the x-coordinate will be 0, forcing a 0 denominator. Discussing reference angles, let theta be an angle in standard position. Its reference angle is the acute angle theta prime formed by the terminal side of theta and the horizontal x-axis. Now that's a lot of words to say. Take an angle, find its terminal side. Suppose we had 120 degrees. We would rotate 120. This would be where our terminal side is. The quickest trip from your terminal side to the x-axis is going to be your reference angle. This chart gives you sort of a methodology to calculating a reference angle. I just go by visual and intuition. So let's check that out on these examples below. Let's find the reference angle for each of the angles given. The first angle is 120 degrees. If we plot that, we have the initial side on the positive x-axis. We rotate 120 degrees counterclockwise, and that's where our terminal side lies. The quickest trip from your terminal side to the x-axis is 60 degrees, and that is your reference angle. Using the formulas above, you would take 180 degrees minus the angle given, since it's in quadrant 2, and then you would get 60 that way. I just think it's easier to visualize. If I go 120 degrees, how much more do I need to hit the x-axis? The middle example is 4 pi over 3. If you need to translate that to degrees in order to get a better visual and know where it's located, please feel free to do that. If you multiply 4 pi over 3 by 180 degrees over pi, your pi's cancel. 3 goes into 180, 60 times 4, that's 240. Anyway, long story short, 4 pi over 3 radians, 240 degrees, same measurement. Plot that angle in standard position. So from positive x-axis, 240 degrees later, we land on this terminal side. How far is it from the terminal side directly to the x-axis? The quickest trip, that's 60 degrees as well. Using the chart above, you would calculate, since this is quadrant 3, 240 degrees minus 180 to get 60. So you have either option. You can either do it visually, or you can use the chart above, whichever one you're more comfortable using. And then finally, we have 300 degrees. Starting at the positive x-axis, rotate 90, 180, 270, a little bit more. That takes us to 300. The quickest trip from this terminal side to the x-axis is 60 degrees. If you use the chart above, 360 minus 300 is 60. Again, I think it's easier just to visualize the quickest trip to the x-axis. Now, using our information from the previous videos where we looked at the sine of different trig functions, this chart down here we've seen before. It's a summary of the 3 main trig functions that we use a lot, and their acute angles and their values. We've done this before. So to find a value of a trigonometric function of any angle, determine the function value of the associated reference angle. And that's what we just did above, was theta prime, finding reference angles. We also have looked at the sines of these trig functions in various quadrants. So depending on the quadrant in which the angle lies, we're going to put the appropriate sine to the function value and then use this chart. Find the sine, cosine, and tangent values of each angle. So if we take 120 degrees at the bottom of your screen, 120 degrees, we have a reference angle of 60 degrees. So what we do, using those 2 steps above, sine of 120 degrees, because sine works off the y coordinates and 120 degrees is in quadrant 2, y values are positive, we put a positive sine, and then we use our reference angle. So sine of 120 is positive sine 60 degrees. From our chart above, that's square root of 3 over 2. Cosine in quadrant 2, cosine relies on x coordinates. Well, in quad 2, you have to go left of the origin, so your x values are negative. The reference angle is still 60 degrees. Using the chart above, negative cosine of 60 degrees is negative 1/2. So now that we know sine and cosine, we actually know a point on the terminal side that's exactly 1 unit away from the origin. Cosine's your x coordinate, negative 1/2. Sine is your y coordinate, square root of 3 over 2. Tangent is the y over x ratio, positive over negative is negative. 60, that's still our reference angle. So using the chart above, negative 10, 60 degrees is negative square root of 3. The problem on the right side, we take an angle. This one's in radians. If you wanted to translate that to degrees, feel free. Multiply by 180 degrees over pi. 3 pi over 4 is the same as 135 degrees. So we draw an angle bottom right of your screen, 135 degrees. Draw in our terminal side. To get to the x-axis, we go 45 more degrees. That's your reference angle. Sine is positive in quad 2, so we have positive sine. The reference angle to 135 is 45. So sine of 135 degrees is the same as positive sine 45 degrees, and the chart above tells us that's square root of 2 over 2. Cosine of 135 degrees, cosine relies on the x values. X's are negative in quad 2. So we have negative cosine of our reference angle. From the chart above, that'll be negative square root of 2 over 2. Sine will be the y-coordinate of the point 1 unit away from the origin. Let me darken this up a little bit. It didn't translate too well. There we go. And under here as well. There we go. So if we take the y-coordinate, that's our sine value. The x-coordinate, that's our cosine value. This point is 1 unit away from the origin. Tangent, the y over x, a positive y divided by a negative x will be negative. Our reference angle 45 gives us a final value of negative 1. I hope this video has helped out. Reach out by phone or email if you have any questions. Ask in class if we are meeting in class together. And have a good day.